We use the term universe to encompass all planets, stars, and distant galaxies. The universe extends beyond human comprehension. Yet this has not stopped us from striving to understand it. Throughout history, humanity has persistently observed, measured, and researched with the hope that one day we will fully comprehend the cosmos. We have made significant strides. But the universe keeps us from becoming complacent by constantly presenting new mysteries and challenges to our imagination. So, the desire to understand the cosmos arose early in human history. Scientists have found Babylonian clay tablets dating from 3000 to 2000 by the long and short of all the days of the year. The Chinese also have records of lunar eclipses from around 2000 BE. Around the world, there remain traces of prehistoric structures aligned with celestial constants. One of the most notable of these ancient astronomical markers is the Newgrange Toned Island, which is over 5,200 years old. At the dawn of the winter solstice, the shortest day of the year, sunlight streams through a passage leading into the inner chamber. On Easter Island in the Pacific, 7 of the hundreds of mysterious stone statues face the sunset during the equinox, a time of the year when day and night are of equal length. It is also believed that the famous Angkor Wat temple in Cambodia was designed to align with the sunrise on the summer solstice, where the sun rises directly over the temple's eastern door. The pyramids of Egypt also demonstrate alignment with the stars, although these structures were not used as astronomical observatories in the true sense. However, they are evidence that their builders had a profound understanding of the movements of the sun and stars. It is almost certain that the ancient Egyptians used astronomical observations to establish a calendar, with the phases of the moon indicating months and the movement of the sun across the sky indicating the length of a day in the year. Over the course of a year, the sun rises and sets at different points on the horizon. The famous Stonehenge is aligned with the sunrise on a solstice, where the sun rises over a stone and yato ring known as the Hill Stone. Initially, it was believed that Stonehenge was a temple dedicated to the sun god, but some researchers have discovered that the stones are also aligned with the moon, leading to the theory that it could have been a prehistoric astronomical observatory. The word cosmos, from the Greek meaning in inward arrangement, is the origin of cosmos and cosmology in English, with cosmology being a branch of astronomy that seeks the most fundamental answers to questions like what the universe is, by stating the movement, origin, and eventual end of the universe. Cosmology became a true science in 1915 when Albert Einstein published the theory of general relativity. Before that, astronomers lacked a mathematical framework to describe the movement of the universe as a whole. Subsequently, cosmology before the 20th century seemed to be a mixture of speculation and religious sentiment. The Egyptians studied the universe based on the reproductive cycle of humans. They believed that the celestial goddess Nut swallowed the sun god every night and gave birth to him every morning. And the varying heights of the sun throughout the year represented the gestation of the sun within the glittering body of the goddess Nut. They believed the sun was reborn each year on winter solstice and returned to the body of Nut through the mouth on the spring equinox. In this way, the goddess continually gave birth, making the universe self-sustaining and eternal entity. Early civilizations wrote many stories inspired by the constellations in the night sky. They imagined lines connecting the stars to form familiar everyday shapes or mythological characters. In Mesopotamia, archaeologists have excavated stone and clay tablets dating back to 1300 BC that detail many constellations, including the 12 that make up the zodiac. These constellations were assigned special meanings because they lie in a region through which the sun passes, and later the Greeks recorded them. For example, the Syrian constellations High Rule and Low became Aries and Pisces, and red streams became Capricorn and Gemini. In ancient Greece, wandering bards traveled from village to village, telling mythological stories about the stars in exchange for food and a place to sleep. Contemporaneous astronomers invented their own stories to explain the nature of the universe. One of the first was Thales in the 6th century BC, who proposed the idea that the universe was filled with water and that the earth floated in it. He believed that the waves of water in space caused earthquakes and that gentler currents caused the stars to drift. The Greek astronomer Claudius Ptolemy in the 1st century compiled a catalogue of 48 constellations. Although from Greece he could not observe the entire sky, so the southern celestial pole was not recorded until the 16th and 17th centuries, when daring astronomers left Europe to complete the star maps of the southern hemisphere. Proposals were also made to fill the gaps in the classical astronomical map of Ptolemy with new constellations. This naturally led to disputes among astronomers with differing opinions. In England, John Flamsteed proposed adding a constellation named Robra, Araminum after the oak tree, in which King Charles chitted a roundhead following the Battle of Worcester. While the king was pleased with this honor, some of Flamsteed's colleagues were less enthusiastic and quietly omitted the constellation from their maps. It wasn't until 1922 that a solid foundation for this issue was built, when the International Astronomical Union formalized 88 constellations with defined boundaries, primarily based on the Greek star maps. These are not the only research from ancient Greek astronomy that is still applied today. A particular individual at that time, instead of creating stories or speculations about the stars, realized that the first step to understanding them was to measure them. He was Hipparchus, who proposed a system for classifying stars that we still use today. Observing the night sky, even a layperson can see that some stars are brighter than others. More than 2,000 years ago, Hipparchus meticulously catalogued 850 stars, recording their specific positions and ranking their brightness. Without a photometer, he estimated brightness with his eyes, ranking stars from the brightest at first magnitude to the dimmest at sixth magnitude. Surprisingly, astronomers still use this seemingly crude brightness scale today. Though modern photometric devices have expanded the original 6-magnitude scale of Hipparchus. At the top of the scale, the brightest stars with negative magnitudes, and at the bottom are stars only observable with telescopes, much greater than magnitude 6 from the Earth's surface. The best telescopes can detect stars of magnitude 24 to 27. However, in orbit, where they are not affected by the Earth's atmosphere, space telescopes like Hubble can detect stars of magnitude 30. Each magnitude is approximately 2.5 times brighter than the one before it. So a star of magnitude 30 is about 3.5 billion times fainter than the brightness visible to the naked eye. However, when measuring apparent brightness, you forget that the brightness of a luminous object depends on the distance from the observer as well as the actual amount of light it emits. Therefore, a dim nearby star may appear brighter than a very bright distant star. This phenomenon follows the inverse square law, meaning if the distance doubles, the intensity of light falls fourfold, and if the distance triples, it falls ninefold. To accommodate this, the unadjusted measured brightness is called apparent magnitude, and the brightness adjusted for distance is called absolute magnitude. The red supergiant star Betelgeuse has an apparent magnitude of 0.58 but an absolute magnitude of 5.14, making it a truly bright star, but quite far from Earth. Conversely, because it is so close to Earth, the Sun has an extremely large apparent magnitude of 26.7 and is the brightest object in the sky. However, when adjusted for distance, its absolute magnitude is only 4.8. In other words, our Sun, while bright and life-sustaining on Earth, is actually a fairly average star in terms of brightness. With meticulous observation and recording, the ancient Greek astronomers left us a vast treasure trove of knowledge about the stars. However, the nature of 5 special stars remained beyond our understanding. They called them planets, meaning wanderers, because they moved across the sky from night to night unlike the fixed stars. These wanderers are the 5 planets closest to Earth that we can observe with the naked eye: Mercury, Venus, Mars, Jupiter, and Saturn. The Greeks of that time did not know these were planets, so they imagined them as gods or divine messengers with the power to change the fate of all living beings on Earth. 2 of these wandering planets, Mercury and Venus, orbit between Earth and the Sun. So when observed from Earth, they are always near the Sun and can only be seen at dusk or dawn. Mars, Jupiter, and Saturn orbit further from the Sun than Earth, and we can see them move slowly across the night sky. Many ancient astronomers meticulously tracked the movements of all the wandering planets to predict their positions in the future. They valued these predictions because they believed that when planets came close to each other, the influences they exerted would interfere and amplify. Thus, the conjunctions of the planets were considered significant events that needed to be predicted when examining an astrological chart. In the early centuries, most people believed that the movement of the heavens would remain a mystery because it was the realm of the gods, while the humble wisdom of humankind would never understand the will of the divine. This perspective began to shift in the early 17th century when Johannes Kepler articulated the movement of the planets into 3 mathematical laws of celestial mechanics. This demonstrated that we could not only measure, but also understand the cosmos simultaneously. In Italy, Galileo Galilei was making discoveries that ignited humanity's passion for the vast universe. In 1609, Galileo pointed his telescope toward the faint, milky band stretching across the night sky, known as the Milky Way. With his rudimentary and small telescope, compared to today's devices, Galileo discovered that the Milky Way was composed of countless stars. This was a significant discovery for humankind as, before this, it was believed the universe consisted only of what could be seen with the naked eye. However, Galileo proved that much more existed beyond simple observation. This realization began a centuries-long fascination that persists to this day, with each generation of astronomers building larger telescopes to see ever more distant celestial objects. The largest optical telescopes today have mirrors up to 10 meters in diameter, 500 times larger than Galileo's telescope. Nowadays, we know the Sun is just one star among a vast collective called a galaxy, which contains at least 100 billion stars arranged in a spiral pattern within a flat disk, rotating around the central bulge. Even more astounding, it contains far more stars than that. From its location on one of the spiral arms, we see this disk is a band of light, the Milky Way stretching across the night sky, observing from a particularly dark location in the southern hemisphere. You might see the Milky Way spread out into large clouds filled with stars. The star disk at the Milky Way center is estimated to be about 1.0 light years thick, with 1 light year being the distance light travels in a year. Empirical measurements suggest light travels through a vacuum at approximately 300.0 kilometers per second. Therefore, in 1 year, light can travel about 9.5 trillion kilometers. The density of stars in the Milky Way's disk is about 1 star every 4 light years. However, at the galaxy's core, about 25.0 to 30.0 light years away from the Sun, the stars cluster so densely that it forms a bulge, extending about 27.0 light years in diameter and about 10.0 light years thick. Our Sun has 33 stellar neighbors within the same star disk, considered neighborhood by astronomical standards, meaning stars within 12.5 light years from the Sun. Most of these neighbors are smaller and dimmer than the Sun, known as red-dwarf stars, which are the most common in the universe. Among these, only 2 stars are of similar size to the Sun, and only one, Proxima Centauri in the constellation of Manas Minor, is larger, with its estimated diameter double that of the Sun with a mass 1.5 times greater. Near the Milky Way's central bulge, the density of stars is 500 times greater than in our region. If the solar system was suddenly placed at the galaxy's center, there will be many more stellar neighbors of the accompanying planetary systems, only about 10.0 times the distance to Pluto. In reality, the nearest stellar neighbor is about 5,000 times the distance to Pluto. At the very heart of the galaxy, astronomers find that the density of matter is so great that it harbors a supermassive black hole. As vast as the Milky Way is, it isn't the entirety of the universe. On a larger scale, it is more like a small island amidst an infinite ocean. Beyond it lies countless other islands, each a separate galaxy containing millions to trillions of stars. Galaxies typically appear in 3 basic shapes: spiral, barred spiral, and elliptical. Spiral galaxies boast a unique beauty with their arms of bright, young stars swirling around a flatter bulge of all the stars at the center. Barred spiral galaxies, like our own Milky Way, are similar to spiral galaxies, but have a bar-shaped bulge in the center with spiral arms extending from the ends. Elliptical galaxies differ completely in shape. They can be much larger than the other types and vary in shape from cigar-like to perfectly spherical. There are also galaxies with unusual shapes known as irregular galaxies. Some of them might once have been spiral galaxies, while others are just inherently chaotic. Spiraled and barred spiral galaxies make up about 3/4 of all large galaxies, which are the most numerous and brightest. However, there is also a large number of smaller elliptical and irregular galaxies, commonly known as dwarf galaxies. Although mini-galaxies are isolated, some are drawn together by gravity to form clusters. This interaction forms groups of no more than 50 galaxies. Simply called galaxy groups, a galaxy is a member of the local group, which includes another large spiral galaxy, called the Andromeda Galaxy, and about 30 smaller galaxies. The concept of galaxy clusters is essentially for larger groups containing more than 50, and sometimes even over 1,000 galaxies. The nearest galaxy clusters to the local group are the Betel cluster with about 1,300 galaxies, the Cone cluster with over 1,000, and the Hercules cluster with about 100 members. Many groups and clusters of galaxies further assemble into even larger structures known as superclusters. These vast assemblies spread across the cosmos along immense sheets or walls that scientists call cosmic webs. If these voids were considered cosmic objects, we would be able to visualize the distribution of galaxies. Imagine the froth on a bath. Galaxies are distributed on the thin walls of the bubbles. The estimated number of galaxies in the universe keeps increasing year after year. Astronomers estimated there were about 125 billion galaxies shortly after, with new cameras installed on Hubble. Many more galaxies were discovered, doubling the estimated number. Today, some computations estimate there are about 500 billion galaxies across the universe. To study the history of galaxy formation and thus unveil the mystery of the universe's evolution, cosmologists have exploited the fact that light does not travel instantaneously through space. Despite traveling fast enough to circle the Earth's equator 7 times in 1 second, light still takes years to cross the vast distances between celestial bodies in the universe. If a star is 100 light-years away from us, then the light from that star takes 100 years to travel across space to reach us, meaning the star's image we see is from 100 years in past. Astronomers refer to this as looking back in time, akin to an archaeologist digging deeper through successive layers of the earth to uncover older fossils. The deeper we look into the universe, the more ancient the celestial bodies we observe. With today's telescopic technology, we can observe the appearance of celestial bodies billions of years ago and trace their development to their current state. Light from a star that is 100 light-years away took 100 years to traverse space to reach us, meaning that the image of the star we see is not from the present, but from 100 years ago when the light began its journey. Astronomers call this looking into the past, similar to how an archaeologist digs deeper through successive geological strata to unearth older fossils. The further we look into the universe, the older the celestial bodies we see. With modern telescopic technology, we can observe the appearance of celestial bodies billions of years in the past and trace their evolution to the present day. The universe is teeming with galaxies that range from isolated like our own to those bound by gravity into groups or clusters. These galactic interactions form groups containing up to 50 galaxies, termed simply as galaxy groups. Our Milky Way is part of the local group, which includes another large spiral galaxy known as Andromeda and about 30 smaller ones. The concept of galaxy clusters refers to even larger assemblies containing over 50 of galaxies. The closest galaxy clusters to the local group include the Largo cluster with approximately 1,300 galaxies, the Como cluster with over 1,000, and the Hercules cluster with about 100 members. Many galaxy groups in clusters further combine into even larger structures known as superclusters. These colossal formations extend across the cosmos along vast sheets or walls, which scientists refer to as the cosmic web. These webs encircle enormous voids nearly empty of galaxies. If these voids were counted as cosmic objects, they would be among the largest structures in the universe. To get a better idea of how galaxies are distributed, one might imagine the froth on a bubble bath. Galaxies are spread out along the fragile walls surrounding these bubbles. The number of galaxies estimated to exist in the universe has steadily increased over the years. In 1999, based on observations with the Hubble Space Telescope, astronomers estimated there were about 125 billion galaxies. Subsequent discoveries with updated Hubble cameras doubled that estimate. Today, some calculations estimate there are around 500 billion galaxies scattered throughout the universe. Cosmologists have taken advantage of the fact that light does not travel instantaneously through space. Although light can travel fast enough to circle the Earth's equator 7 times in a second, it still takes years to cross the vast expanses between celestial bodies in the universe. If a star is 100 light years away from us, its light takes 100 years to travel through space to reach us, meaning the image of the star we see is not from the present, but from 100 years in the past. Astronomers call this phenomenon looking back in time, similar to how archaeologists dig through successive layers of soil to unearth older artifacts. The further we look into the universe, the older the celestial objects we observe. With today's telescopic technology, we can see the shape of celestial bodies as they were billions of years ago, tracing their progression to their current state. This process of observing distant celestial bodies allows us to piece together the history of the universe by looking at stars, galaxies, and other objects billions of light years away. We're essentially seeing them as they were billions of years ago, providing a glimpse into the early universe. This method is akin to a time machine, allowing astronomers to observe the formation and evolution of galaxies, the birth of stars, and other cosmic events that shaped the universe as we know it today. The technology used in astronomy has evolved tremendously over the years. From Galileo's simple telescope to the sophisticated space telescopes like Hubble, each advancement has brought us closer to unraveling the secrets of the cosmos. These telescopes have allowed us to detect galaxies at different stages of their evolution, providing crucial insights into how they form and change over time. In the field of cosmology, one of the most significant discoveries has been the realization that the universe is expanding. This was first proposed by Edwin Hubble in the 1920s when he observed that galaxies are moving away from us, with their speed proportional to their distance. This discovery laid the foundation for the Big Bang theory, which posits that the universe began as a singular, incredibly dense and hot point, and has been expanding ever since. Further advancements in technology have led to the discovery of dark matter and dark energy, two of the most mysterious components of the universe. Dark matter, which does not emit light energy, is thought to make up about 27% of the universe, while dark energy, believed to be driving the accelerated expansion of the universe, accounts for approximately 68%. The ordinary matter that makes up stars, planets, and everything we can see constitutes just about 5% of the universe. As we continue to develop more advanced observational tools, we inch closer to answering some of the most fundamental questions about the universe. The James Webb Space Telescope, set to be launched as the successor to Hubble, promises to provide deeper insights into the early universe. In conclusion, our understanding of the universe has come a long way from the ancient observations of the night sky. Each discovery builds upon the last, taking us one step closer to deciphering the vast, mysterious cosmos that surrounds us. As we continue to explore and study, the universe reveals more of its secrets, each more fascinating than the last, and reminding us of the never-ending quest for knowledge that drives humanity forward.